Yeah.
Okay.
Good evening and welcome to all. I'm very happy as part of the Teaching Learning Center at SASTRA, inviting all of you for the 9th TLC Talk series. And today we have a very special guest, special in a sense. She is a SASTRA alumni, a chemical engineering alumni from SASTRA. Is Anjali Nambiar, one of the very earliest batch where I took classes for her, and that has nothing to do with this. And she went on to become a very good educationist, something deeply caring about how people learn. I'm not going to read out the complete biography, but just for the sake of a good formality, I just want to recapture. After her bachelor's in Shastra University, I think she took up the Teach for India internship. I think that is where I think she understood her passion in the realm of educational field, and especially teaching for kids who are not in a very comfortable atmosphere or in a very vulnerable situation. And that curiosity kept, I think, moved her to so many countries, projects involving education across Asia, Africa, and US. She eventually pursued her MS in public policy, public affairs from University of California, Berkeley, in the very well-known Goldman School of Public Policy. She had worked in state ministries in India as part of the internship projects in NEP, Nipun Bharat Mission, and currently in US, continuing the same educational field. Today, she is joining in her personal capacity, wherein she wants to share her experiences of teaching learning in the AI era, especially how we can make the AI tools probably to better enhance the learning process. I'm very happy to have in the participants some of my colleagues, students from Shastra, and also the teachers from primary, secondary, and higher secondary, and alumni as part of this TLC series. Anjali has been passionate about, like, she wants to talk, and I think now it is very early morning time. It was 9 o'clock. And if she was in California, it should have been like 5:30 or something like that. Nevertheless, that's the enthusiasm, and I'm very happy to have you, Anjali. Anjali, over to you.
Sure. Thank you so much, sir, for that. And, thank you so much for inviting me to this talk. I think you've been following up for a long time, and I'm glad that we could make this happen. And it's wonderful to be back, virtually, but be back at Shastra to be able to give this talk. I think I will start with a quick Mentimeter survey, just to understand, what is the kind of
Okay.
usage of AI across the audience here. So I just
Great.
shared a Mentimeter link.
So you want to share the screen?
Yes. Are you able to access the link though? Are you able to see the...
So you put it in the chat?
Chat, yes.
Yeah, the Mentimeter link is in the chat. Yeah, I'm able to access. I assuming that participants are also able to. Yeah, participants are there in that link already.
Okay, great. So if you can take a few minutes and respond to that first question. I'm trying to understand how often people here are using AI in a week in their professional capacity. So for teaching or for learning, how are you using AI? Hoping we have a few responses. Okay. So you can see that there are a few people who are using it daily.
Oh, you're showing the results. Okay.
Yes. There's one person who doesn't use AI at all, which is always something that surprises me. Sounds great. Most people are using it daily. There are a few who are using it once a week, or maybe a few times a week. That's great, just to see that range. I think I'm going to move ahead to the next question. So the next question is, if you do use it, yeah, in what ways are you using it in your teaching learning currently? So you should be able to type in probably like a word or a phrase. Okay, we have 2 people who responded. Okay, I can go ahead and start sharing screen. Okay, so someone's saying solutions for problems, lesson plan, framing questions, motivation of the topic, preparation. Great. Structuring. And most of my experience has been in the school education space, so it's great to see a lot of teachers here. Amazing. Second opinion tool. Okay, that's wonderful. Okay, great. So it looks like, there are a range of different ways in which teachers and students are using it. And it's something that it's not new, and it's not something that people have not experienced before. And people are creating really interesting use cases with it. So with that, I think I'll start my presentation. And I think, yeah, answers are coming in. But thank you so much for sharing that. So today's talk is about the overview of AI in education research. And just a second, I'm just going to share my screen.
I think you're sharing the screen, right?
Yes, can you see my screen?
Yeah.
Okay.
Yeah, it is getting shared. Yeah.
Okay, great. Yeah, so today we're going to talk about overview of research in AI in education. And I want to start with some use cases in education, which I think most of you have already spoken about, and it looks like, there's already very good usage, and um, how you're using it in AI in your education practice is quite widespread. But I thought I should just put that out in terms of from the perspective of educators and from the perspective of learners, what are some use cases? Many of you already mentioned lesson planning, assessments, and even like personalizing content, and also evaluation and feedback. For the learner's perspective, learning a new topic or probably researching something new, and also getting one-on-one support. So these are some examples. But the main idea and the main sort of crux of this is to say that are you using it in an ideal way where the AI is augmenting or improving how a human is engaging in teaching and learning, or is it being used in a non-ideal way where it's undercutting what a human can actually do. It's not really increasing the learning of the student, or it's basically helping the AI develop but not the actual student or the teacher. So that's, I think, a very important lens to have, to say, are we using it in an ideal way? And to make sure that we are using it in the ideal way, it's really important to have research about how AI is supporting these ideal use cases. So, again, AI is a very evolving and emerging space in education, especially. And there are some research areas that a lot of people are thinking about right now. And I'll quickly talk about some of these areas. And I've bucketed it into 3 different sections. So the first is efficacy, where you're thinking about can AI really help with the teaching and learning process and help with improving student behavior, student engagement for the learning process. The second category of research mostly falls into the equity bucket, which is to say, who benefits most? Is it students who are um, under resourced, or they don't have the resources to get human support, so then AI support is something that helps them? Or is it people who have the AI tools but then can pay for the higher models, are they the ones who are benefiting from it? So there's a lot of questions that need more exploration in that area of equity. And the final piece is about ethics, where there are a lot of open questions about how the data being collected about the student, especially for an education purpose, how is that being stored? Is the data appropriate? Is that taking a lot of personal information from the student? And when the AI is interacting with the student, is it acting like a human, and if that acting like a human is a good thing or a bad thing? And that's mostly called anthropomorphism, where the AI is acting like a human in a way that it's connecting very well with the students, but students are a very vulnerable category of society, and there's still a lot of questions about how they become very dependent on this AI tool, or become very dependent on an AI companion almost. So many open questions there. A lot of policy questions are also looking to more research in these areas to be able to inform policy and regulation and law around how AI should be used in the classroom with students. So yeah, this is to just give you a sort of lay of the land. For today's talk purpose, we will be looking mostly at the efficacy bucket to say how does it inform the teaching and learning process specifically. And yes, if you have questions, please keep putting it in the chat. I think I can either answer it right then or we can come back to it towards the end.
Yeah, I have also just put it in the chat
Okay.
that there's a question icon there, so people can put it there also.
Okay.
So and then maybe we can pick it up at the end.
Okay.
Yeah. Go ahead. Yeah,
Okay.
go ahead.
Okay, so like I said, it's very important to have this research to inform how AI is being applied in the classroom and in education purposes. So to ground this discussion, I want to introduce these two concepts, which is learning science and learning engineering. Some of you might already be familiar with these terms, and I also saw that there was another TLC speaker who kind of spoke about some of these topics. So I'm just going to quickly reiterate some definitions almost about these two concepts. So the first one is learning science, and that's primarily about how people learn and how both children and adults, how are they processing information, how do they build on their knowledge and develop in a cognitive fashion. So that's the theory part of it. And the engineering part of it is where this theory is getting applied in real world settings, where you're designing learning systems and you're applying this theory and you're testing it. And then there's a lot of iteration that keeps happening. So it's a continuous cycle between these two disciplines. So there's a theory and then you apply it and then you test it and then the system keeps improving. So this is almost the sort of cycle that forms a basis for any research work in AI in education today. Quickly, I'm going to give you a quick, history point of view for how learning engineering emerged. The roots of this go back to 1960s, where there was no AI, no technology in the classroom, but there was this Nobel laureate at Carnegie Mellon University who thought that we should have a systematic way in which teaching learning improves in the university, and this is very similar to what the Teaching Learning Center at Shastra is aiming to do. So that's how it began. That's how its conception was, and from there, if you fast forward to 2014, Carnegie Mellon University started an initiative called the Simon Initiative to really bring together different disciplines across education, cognitive science, computer science, to really formally build this space of learning engineering. And from there, in 2017, IEEE started this international consortium for innovation and collaboration in learning engineering, which was a global community that has a lot of events and collaborative spaces for people to learn more about the learning engineering space. And this is open for all. I mean, you can definitely go out and check their websites and all the resources that they have there. And I would highly, recommend doing that, because they have a lot of free events and resources there. And finally, in 2023, Arizona State University has started launching dedicated programs focused on learning engineering. So you can get a master's in learning engineering or do PhD studies in that subject. So that's the sort of evolution of the field, where it went from a concept to a structured field to right now it's quite a global concept, and it's an ecosystem that's growing, especially because of the AI in education, boom almost. So that's a little bit of a history. And now going forward, just to make this more concrete, to say, how do we actually apply these principles to run an experiment or run a research project in a learning engineering space? I'm just going to quickly put down the steps, and then we'll also go through a real experiment which followed these steps. So the first step is to start with a hypothesis. And it's important to have these ideas and think about testing it out. So if you're saying that AI is used in, say, lesson planning, you might want to test out whether your hypothesis that AI is actually improving the learning or the lesson plan creation process is true or false. So that's the kind of hypothesis creation that you start with. It's very similar to any scientific research process, but this is more rooted in learning science and the learning environments. So once you have a hypothesis, you define the different research questions, where you break down the hypothesis into measurable questions. Once that's done, you think of, how can you select different metrics? So you select the appropriate metrics, and then you decide how you will measure success to say that, yes, the hypothesis was true, or, I think this is wrong. Maybe we shouldn't use AI for this particular application. So that's the third step. And once you have the metrics, you design an experiment where you structure a process in which, you try to actually delineate whether the particular intervention or the particular use case actually made a difference in the learning of the students or in the teaching of the teachers. So that's the fourth step. And then you go ahead and test it. So actually run the experiment. And once the running of the experiment is completed, there's a lot of data analysis that happens towards the end. And once that is completed, you look at the results and make certain decisions about, whether the hypothesis was correct, whether you validated the hypothesis, or do you want to refine it, conduct a new experiment to prove maybe a different hypothesis. So that's essentially how you would go about any learning science research. And this is very much, possible in a school setting or university setting. And it really does have very significant value, especially for the global context. So now to make it more concrete, I'm going to talk about a real example. So this is a research that I had the opportunity to be part of as part of an organization called ED. And this was a study that was conducted in partnership with Google DeepMind, which is a research lab at Google. And along with them, we conducted this research where AI was used to support in a tutoring intervention. So tutoring is basically where students are supported in a very small group. So either it's one-on-one support, or maybe 1 to 3 students getting support from one single teacher. And that's why tutoring is different from teaching. That's just the difference in the nomenclature. So moving ahead, this was the sort of hypothesis that we were testing from this experiment. Again, at any point, if there are questions, you can go ahead and probably, yeah, pause, or if you want me to like slow down, please let me know. But I'm just going to keep going through now. I can see some questions here, and maybe I can come back to it towards the end.
Yeah. So there is one question. You want to take it now, or we will take it at the end?
I think this I can take it towards the end, since it's not about this particular research. Does
Yeah.
that sound okay?
Yeah. It is not about this. Yeah.
Okay.
It is
Okay.
not about this.
So
It
I'll
is in
come back.
general. So we can take it at the end.
Okay. Okay.
Yeah.
So yeah. So about this particular
Go
research,
ahead.
sure. We were trying to test the hypothesis that AI tutoring can effectively support students in their learning. So, to say that if there is an intervention where students get AI tutors, they will be able to perform better in some kind of exam. And this is grounded in a learning science concept that was introduced by Lev Vygotsky. I think some teachers might know about this, but for those who don't, it's about the concept of a zone of proximal development, which refers to this optimal learning zone where students are not given a challenge that is too easy, because at that level students might get bored and they might not engage with the learning activity, or it's not too difficult where they feel too overwhelmed and feel like, okay, this is absolutely impossible, and check out of that learning process. But it needs to be in that right level of challenge where the learning is maximum. And the promise that AI gives in this situation is that it can actually have every student be in their zone of proximal development throughout the learning experience. In a typical classroom, it's very difficult for teachers to do that at a very individual level, where you're personalizing for every student's almost zone of proximal development. But an AI tutor can do that if there is enough information about the student, enough data about the student, you have their past performance, and it can also adjust in real time. So as a student is engaging with the learning content, they will be able to get the appropriate level of difficulty or challenge. So that's the hypothesis that most AI tutoring platforms are testing, and that's what we were testing here as well. To go on to the next step, which is thinking about a research question, for the purpose of this talk, we'll talk about just one of the research questions. There were 4 questions in all in the paper, and I would highly recommend you to go ahead and read the paper. It's around 10 to 15 pages, very easy to read. But for today's purpose, I'm just going to focus on this question about how does interactive AI support, interactive AI tutoring support compared to only human tutor support. So we were trying to compare and see whether if only a human is giving support, does that, like, how does that look different from if there is an AI supported tutoring process? And the next step was to think about the metrics. So we thought about 2 different aspects. So one was misconception resolution, and the second was knowledge transfer. And for misconception resolution, um, there were different ways in which we did that on the platform, but I don't want to go into too much depth. But I'll just say that the idea was that students can have different kinds of errors that they make, so they can get questions wrong because either their concept is not clear, or maybe they don't know the procedural way in which you should do certain questions. And over here we were focusing on the conceptual error, and saying that through AI tutoring we can resolve the misconception. So we were trying to look at the rate of misconception resolution. That was the first measure to say whether AI supported tutoring is better than human only tutoring. So that's the first metric that we identified to measure this experiment and see if it's if it's positive or negative. The second metric that we looked at was knowledge transfer, to say that if students receive support on a particular problem and they solve that using the support from the AI or from the human, if they're given a next problem, or if they're given something that builds on this initial question that they responded to using the support, in the next question, are they able to transfer the knowledge that they gained? So are they able to apply that learning to a new problem, which showcases that the learning that they had was durable, that it was something that is long term and not just like a short term thing. So those were two metrics that we chose to prove or disprove that hypothesis, and to think more deeply about AI in tutoring use cases. Going to go ahead and talk about the next step, which was the experiment design itself. And here, what we did was we had 165 students who were in the age group of 13 to 15. And all of them were working on this math practice platform, which was called ED. The students had already learned some maths concepts in the classroom. The teacher would have taught them those things. But this platform was just giving them practice. And the idea was that during practice, if they got a question wrong, at that point, they would be taken into one of three different conditions. And this was a randomized control trial where students were randomly put into these three buckets of groups, in such a way that, across all the three groups, they were completely similar, except for this extra, intervention that they were getting, which is either they were getting a static hint where if they got something wrong, they would just get a pop-up that was pre-written. It wasn't really a tutoring conversation. So that was the first group. The second group was where they would get a human tutor. So if they got something wrong, a chat window would open on the side, very similar to what you can see over here on the right. So there would be a chat window, and the students would engage in a chat, either with a human only, or the third group of students would get a AI plus human tutor. And in that case, what would happen is the student's response would go to an LLM. And in this case, we used LearnLM, which was Google's pedagogical tool at that point. Right now, it's all into Gemini. Sorry, does anybody have a question? You can see Deepthi. Okay, we can continue to move forward. So yes, so the third case was where there's an AI tutor, and there is a teacher in the loop. So the answers from the students was going to this LLM, and the LLM would create a response, and that response would go to a teacher who would have to either approve it or make some changes or disapprove it and write a whole response on their own. So what you can see on the right here is an example where the LearnLM or the LLM created an answer, and this tutor that you can see in that small picture, the tutor's gone in and made some changes to the response that the LLM gave. And once she's made that change, then she hits enter, and that message then goes to the student. Yes, did the student know that they're helped by AI? Yes, they did. They had to, we had a whole opt-in process, and this was completely, looked at by an ethical review board. And as part of the ethical processes, we had to tell the students that they were going to be part of an experiment in which they might be in either of these conditions. So they didn't know which condition they were in, but they knew that there might be a case where there might be an AI that they were talking to, or there might be a human that they were talking to. So they were informed about this, parents were informed about this, schools were informed about this, but they wouldn't know which group they're in, so that doesn't affect the behavior of the student. And the students did not have a choice. It was randomized. So, we basically created a random number generator and just put students in different groups. And this was basically the process of how randomized control trials happen, and to make sure that the results were robust. So So those are the three cases. That's how, the setup was, and this was run between May to June of last year. I'm hoping that that setup was clear, because now we'll be going ahead and seeing what we found from the experiment. And to just quickly recap, these were the research. This was the one research question that we're looking at now, which is whether AI supported tutoring was better or worse than human tutoring. And these were some of the metrics that we identified. So these were the results for this question, where, as you can see, with a human tutor, with just having a human tutor, 94% of the time, their misconceptions, 94.9% of the time, their misconception was resolved. And when it was a human plus AI tutoring, it was 95.4%, right? So the difference is 0.5 percentage points. It's very small, but it is quite significant, because this means that an AI supported tutoring performance can be at par, or in some cases even better than human tutors. So it is possible to scale this support with AI tutoring across hundreds of thousands of students. That's like a big proof that came out of this, a big highlight of this, the research, I would say. The second part, which was even more interesting, was whether the knowledge actually stayed with the student when they did a second sort of study unit. And in that, what we see is quite interesting, where with the human tutor, it was 60.7%, versus with the human plus AI tutor, it was 66.2%. And there is a 5.5 percentage point improvement, which again looks small, but it's really meaningful in that AI in education community, because it's really hard to achieve knowledge transfer when it comes to AI tutoring. And this, this example really proved that if you have a very, good design in which AI is introduced in a very thoughtful manner, it can have positive impacts. And that's the sort of key takeaway from this experience, from this experiment, I would say. Again, this is a very watered down version of the research, and there are a lot more other questions that we tried to answer through this experiment. And I would again, encourage you to go ahead and read it for sure. Now, what's happening next from this is that the team is running a larger scale study where we're going. So this was with 165 students, and right now they'll be doing it with more than 1,000 students. And that will ensure that it is statistically robust. This was not statistically significant, just from a research perspective. We may not be able to say that we'll get this result every time we do this experiment. But if we have a larger sample size, basically larger number of students that we do this experiment with, we can say with confidence that every time you repeat this experiment, you will get similar results. So that's what is the next step from here. But this is a good indication, and it's quite promising to say that, okay, we should probably do it at a higher scale to see if it's actually, there is, it's not just correlation versus there is causation. So that's an example about a research that actually applies these learning sciences principles and learning engineering. And it is also iterative. Like I said, from this result, there's a decision to do another round of experimentation again. So that's one example from a school setting that I've spoken about. Just moving forward, I'm just going to quickly talk about some higher education related use cases. Again, this is not the core of where I work, but I've been privy to some research papers and projects in this space, and I thought probably I can quickly share. These are some specific applications in the space of higher education, which again is very similar to what we saw in the K-12 or the school setting. But here what you see is it's a lot more self-directed, or it's based on students taking up the learning on their own. So for the assessment, it's more from a teacher's side, where the teachers are grading, or like the faculty is grading or giving feedback on subjective student work. So essays that students are submitting, and that's the kind of assignments that at a university level students would submit, versus being MCQs or true or false kind of questions. And then also like generating these questions and generating assessments. The second area that I've mostly seen is in the prediction, where you're predicting the academic performance of students, say some months down the line, to make sure that they have the kind of support that they need to continue in the university system. The other one is about the dropout rate, to see if students are going to drop out at some point, given all of their background information. So that's another area in predicting that AI has been used. And the final space is in learning, where I think we spoke about the intelligent tutoring systems already, but this is more from a university standpoint. And the final is more from a research perspective, where a lot of students are conducting research. You're looking at research, literature reviews. So in such spaces, how does AI get used? That's the third application. I'll quickly talk through some examples of research from higher education as well. And these are two examples that I'd probably quickly talk about. One is where in Germany, they tested this out, where students were given either ChatGPT or just Google search to do a research project. And what they found was that students who used ChatGPT, they said that it was easier to conduct the research and to produce some research artifacts. But at the end, when they were tested on their reasoning and argumentation, you could see that they were not able to construct those arguments themselves. And so this indicates that even though it made things easier for them and it lowered the effort, that does not mean it improves the learning. And in most cases, it does not improve the learning, which is caused due to the fact that you're shortcutting the critical thinking process in the student's mind. And that's something that you really need to be wary of, to say that you don't use a tool just for the ease of it, versus you need to go through that productive struggle almost to be able to learn better. And that's something that you need to train students and train their minds to sort of work through, to be able to actually learn and build their knowledge. So that's one experiment. The other experiment was quite similar, where they tested out an essay writing process. And there were three conditions. The first group got AI, the second group could only use search tools, and the final group could not use any tools. And in that, in terms of recall, so when you ask them to quote something from their from the essay that they submitted, or talk about some arguments that they put into the essay, only 11% of them could 83% of them could not quote an essay if they used AI, versus if they did not use AI, only 11% of them could not quote something that they put in the essay. So again, this talks about how there's no internalizing of knowledge that happened. It was just something that the AI produced. The AI became better, but the human didn't. So again, there are these use cases where you can use it, but it's always important to think about whether it's actually augmenting the learning and teaching process. So that's just to emphasize that. I think finally, I'm just going to leave with this, where again, this is from a research that was conducted in 2023 about the global distribution of AI in education, in higher education research. And you can see that there's a great scope for research from the Indian higher education context. And I really think that institutions like SASTRA, with this kind of TLC process, can really contribute to the global research space. And I'm really looking forward to seeing more of research coming out from these spaces, and really critically thinking about how AI is being used in the education space, and not just blind adoption of the tools, and of how it's percolating into education. So I will stop with that. Um, and yeah, just if you want to learn more about learning
Yeah,
engineering or AI, these are some spaces that you can go into and learn more about it. And you can always reach out to me. Yeah, I think that's about it from my side. If there are any questions, happy to go back and go in.
great, great. So Anjali, that's fantastic.
So I
Right?
can't hear you.
Uh, am I audible?
Not
Are you
able to
able to
hear
hear
you
me?
now.
Okay. Okay.
Are you able to
So
hear
am I
me?
audible? Yes, I'm able to
Okay.
hear you. I'm able to hear you. Uh, so you can
I
see
can't
the
still hear you.
question chat box. Probably it is network. Can you see the
No, I'm not able to hear you.
question box? Attendees can put the questions in the question box.
I don't know what's happening. Should I
Okay.
try
Are
to
attendees
rejoin?
able to hear me? Uh, okay. So that means I'm audible.
Yes.
Right.
Oh, I could hear you in
Yeah.
between and then it went back.
Yeah. Okay. Right. Good. So I think in the question chat there are some questions. Maybe I can read it for you.
Let me try to rejoin again.
Yes. Uh, are you still not able to hear me? I think we'll wait for Anjali. I think she will rejoin.
Hear you now.
Yeah. Are you able to hear me,
Yes,
Anjali?
yes, I can hear you now. But I don't have any of the chat.
Yeah. Good.
Oh, yes, I do. I do.
So yeah, the questions. There's a question mark, right? So where this first question
Yes.
is from Aravind RH.
Okay. So whether introducing AI at all levels of education will be viable in the long run? Um, I would say that it really depends on the use case. Like, how do you envision AI to be used? Um, if you're talking about, high school or like s- higher grades, probably it can be used. But when you're thinking about lower grades and students in say KG, and maybe below say an age of probably 13, you really need to think about whether it makes sense to integrate AI in the education process, because the benefits may not be as high as the costs that are involved. So you really need to think about it very deeply. So I wouldn't say whether it's viable or not. I really think it depends on what the use case and what the intention behind doing that integration is. I hope that answers. I hope that answers your question.
Yeah, the other two questions are actually from me, so that's why
Okay.
it is in the name
Events.
events
Okay.
because
Okay.
I'm an admin. I think.
Okay. Got it. Yes, I think I answered this question about does the student know if they're helped or not. Like I said, they had an opt-in, opt-out um, process at the beginning, but they did not know which group they were in, and they did not have a choice. It was completely randomized, again, for like
Okay,
robustness of the research. Um,
but then why there was no AI tutoring alone?
yes,
There was no AI tutoring alone, right? You had human, and AI.
correct. So that was mostly because we were not sure of how the AI responses are going to be, whether it's going to be harmful in some cases. We didn't want the AI to directly be interfacing with students. So that's why we had like almost like a filter in between where the tutor would see the messages first. And this was more of a human in the loop design. We saw that 74% of the messages that the AI created was, sent by the tutors without any changes. but the rest of the 24, 25% of the responses had to be changed, or had some changes to be made by the tutor. And there were some factual errors as well, for like very, very small
Okay.
number of percentage of the responses, but there were some factual errors. So we didn't want to expose students to those errors right at the beginning.
Okay.
Yeah.
So that means you must have done then some pattern analysis also based on what was asked and
Yes.
what was asked by the students, I mean the children, and what was done by the LLM.
Yes, yeah. So we have an entire database of that, and the team is planning to make that public. So you can see the response from the
Okay.
student, the LLM, and what finally got sent out by the teacher. And we have a huge data set of that.
Yeah, great.
Yes,
Another question from Dr. Madhavan.
yes. What specific strategies you would suggest for making intelligent use of AI, given retention and originality are lower when students use AI? Yeah, no, that's a great question. In terms of strategies, I think it comes down to the idea of critical thinking and, being slightly skeptical about AI tools, to say that it's not like the silver bullet. It's not going to completely overturn education, versus it's a tool. It's like the internet probably, or like any other tool, which if used well can produce good results. If it's not used in the appropriate way, it can have negative results. So I would definitely say, think about the kind of research that's coming out. Some of them are very surprising, where you might have thought that AI would be helpful in a particular use case, but when you go into the research and actually conduct an experiment, you realize that it might not be of the kind of service you thought it would be. So yeah, maybe like staying on top of the research, being critical of the way in which you use AI, and also supporting students to think through it in a critical manner, to say, is using AI the best way to go forward for this particular problem? Yeah, I'm hoping that's helpful.
Yeah.
Does the
So
use
there are
of
two more questions.
Yeah, sure. Does the use of AI in education promote independent thinking or create dependency among learners, which lead to cognitive decline? Yeah, that's again a great question. I would, I feel like I'm saying the same thing again and again, but it is about thinking about, um, what is the right use, or like how are we using AI? It can help in independent thinking if you're thinking about, um, helping you think through a problem in a Socratic manner, maybe. So where, the AI doesn't give you the answer, but it keeps giving you these leading questions where you're asked to think in a different way because of the AI. And it's basically doing the work of somebody who can help you think through different viewpoints. So if that's something that AI is helping you do, that's definitely going to increase your independent thinking. But if you're going to just ask AI the answer, or you're going to shortcut your learning process, that's when there'll be a lot of cognitive offloading, which is basically saying that your cognition is not developing. You're just giving it off to the AI to do the work, and you're not going through that productive struggle almost, which is a struggle that you go through to learn, which will be a struggle, but then it does have a productive effort towards the end, and which is mostly where education and learning happens. So I think like keeping that in mind would help you always critically think whether you're using AI to build your independent thinking, or are you creating a dependency on it?
So the words cognitive offloading and productive struggle,
Mhm.
right? It is just fantastic. I think you should come and speak to students, because I mean, at least if you come back to Shastra and like say address all the students, or chemical engineering in particular. Now I know that this was a student, and now the student is addressing an alumni. these two words are of, I mean, they have a very deep meaning in terms of the productive struggle. There needs to be a discomfort to first learn. Learning does
Exactly.
not happen cognitively in a very comfortable way. I'm not talking about the other external
Yeah.
comfortness, but I'm talking about the cognitive comfortness and the cognitive offload. I think there was also an MIT Media Lab study which was saying that if people just keep on using Gen AI, they were kind of imaging the
Brain.
pattern in
Yes.
the brain,
Yes.
what parts of the brain gets actually activated, and it seems that there was very less area that was getting activated if people were using to offloading the cognitive process. I think
Exactly.
there was one, I could not see the question, but I just saw from Ishwari Jayaraman. I
Yes.
have a robot teacher assistant with 60 use cases at Kumbakonam. So
Okay.
I think uh, she is from the SRC Kumbakonam,
Okay. University.
the school.
Yes.
I have tested all these use cases with students. I think
It's a
she's
comment.
probably, is this a comment or
Okay.
an opinion or something like that.
Okay. That's great.
The next is from Purani.
Really.
Purani is a final year chemical engineer. Yeah.
Okay.
So
It was
you're
an
junior.
okay. If AI can learn from us, are we also unconsciously learning to think like AI? And when AI can answer anything instantly, what exactly are we still training our brains to do? So that's a very, deep and philosophical question. Um, in terms of if
She
a
will do a learning science PhD.
Yeah, I think so too. uh, so if AI can learn from us, are we unconsciously learning to think like AI? That's a very, very interesting question. So the organization that I'm currently working at, we're trying to do this experiment where we are asking the same question to AI across multiple timelines. So, every week we might go and give the same question, see what the response is, and we're tracking that response to see if there are any trends in which the responses are changing. One is to see, yes, whether what we're reading in AI is helping us or changing the way we think, and two is also trying to understand if these AI responses are changing the way society thinks, or how society is evolving. So there are certain things that people are not talking about, or like the different administrative changes that are happening. We're trying to see if that's percolating into AI's responses, and whether AI's responses are changing almost like the societal narrative about certain topics. So again, this is very new a field, and I would just say that if you're interested in this, there's a lot of scope for research, and you should really consider thinking, I know I'm taking away people from chemical engineering, but I think this is a great space to get into right now because it's emerging. These are the kind of questions that people are asking in, you know, huge institutions, and they're still struggling to, find answers to it. So that's great that you're already thinking in that direction. And
Yeah, I think I mean Ishwari Jayaraman. I think she is from the school. She is from the Sandipani Vidyashram School of
okay.
at Kumbhakonam.
Yeah,
I mistook it as so. That means it's, I'm happy. This is already people are doing engaging in this kind of AI education research. So
yeah,
that's
that's great.
nice. Anybody else? I think there's we have reached the end of the questions. Anybody else wants to unmute and ask? Uh, I think I have given mic access almost to all, I suppose. We'll just wait
Sure.
for so for people to think.
For sure, yeah.
We are not AI, so we need to reflect.
Definitely.
But the higher education part is what, by the time we'll just wait for a minute or so. But in the meantime, the higher education part, where you are rightly pointed out, it is actually the cognitive aspect, the critical thinking aspect is what is going down, and that is where at least I'm teaching to higher education kids.
Yes.
So I'm teaching to college,
Yeah.
right, university
Mhm.
kids, and where instantly we cannot always kind of see what the students are doing. I mean, I cannot have a lens and monitor them what they are doing it, because even if I monitor in one device, they will can see in other device, because they are more independent as an individual after 18 years.
Mm-hmm.
And that is where they need to frame their own learning values,
Exactly. Yeah.
one. And then they need, there's an increasing importance of making students at, I mean, the higher education, not just 11th 12th, but I'm saying in the university system or in the college system, making them aware how to use that AI, because it is very easy to use AI to just get solutions, and then once you get used to the comfort, you don't realize that your cognition is getting lost, or by the time you realize, the damage is actually gone very deep. And then that means there are actually cases like where the students come and tell that I used AI, but I said, did you know whether what AI is given is right or
Yeah.
wrong? And that seems to be conceptually incorrect in equation. It looks so similar, but there are plus or minus in like kind
Yeah.
of thermodynamics is gone wrong, and it's everything gone wrong. I said, it's okay, you didn't see the book, you didn't see
Yeah.
something, the written material, but did you know that what it is giving is correct?
No, for sure.
Is it clear?
Yeah, and most AI tools, especially for like mathematical concepts, they definitely do have this hallucination problem, which I think you must be aware of, where it it's basically creating things from a statistical point of view. So I think that's very important to keep
Yeah.
reiterating that it's just a statistical model. It's not, when you associate this more than idea to it, to say that it's some magical thing, I think that's when people use it in a way that they just get the answers from it, versus iterating that it's just a statistical model that is giving you probabilistic answers, like things that are probable in probability. This is what the answer would be based on the training data. So, you know, really breaking down what AI is, because right now it's become this, larger than life thing. But it's just a tool or something that I think we need to keep iterating. Um, yeah, there's a question of
Yeah, good. So we,
how can we ensure.
yeah, there's one question, and then we will, yeah, how can we ensure students use AI as a learning aid rather than becoming dependent on it?
Yeah, I think one one aspect is also where the AI is being given this, like I said, like its own life, where you're talking about talking to the AI and getting answers, or you're looking at AI as a friend versus just a tool. And I think that's like a reorientation that needs to be done among students, to tell them that it can be wrong, it has issues, you really need to be questioning the responses and outputs from AI. And the use cases need to be very precise in a way that the human angle from it and the human expertise from it is not lost. So even in the example that I spoke about, it's at a very precise moment that AI is introduced, and then it goes back. Where you get a question wrong, that's when the AI comes in, and then that's it. You got that question correct, the AI leaves, and then you're doing your normal learning process. So it's very important to, one, question it and do research around it, to say, yes, you think AI is going to help you with, say, ABC. Have you proven that? Like, are you really proving the fact that if AI, you think that AI will help you with, say, essay writing, is it helping you with that essay completion, or is it actually helping you write essays or build the skill of writing essays? So that's a differentiation that you want to do, to say, are you using it on an event basis, or are you using it for a long term learning um, experience and building your learning skills? So that's, I think, a differentiation that teachers, especially, I think, need to keep reiterating, telling students about this. Just to quickly also add, students are feeling this because, after, say, engineering, when they go out into the real world, there are occasions where you need to, use your knowledge. And that's where students are struggling right now. And there's been a lot of conversation about how students are pushing back against AI in universities, to say that please ban AI so that we can actually have the learning experience. So there are some cases where this is also starting
So
to happen.
yeah, so I think we are in a kind of an learning epoch where the pattern of learning is probably going to change with this super duper tool that we have it,
Yes.
an extraordinarily powerful tool which probably we have not seen in the last whatever, like say modern education
Yeah.
frame of 300 400 years. We have not seen that, but I think that human brain, as humans, we are resilient. We will just adopt to
Mhm.
it, and probably we are in that transition phase. We'll
Okay.
come out with it, and then it's not about no to technology. It is about like understanding technology, and I think that calibration is what is now going on.
Exactly.
I think, yeah. So maybe I think we are already past 7:30. Is it fine to end now? I mean 7:30 in India
Yeah,
now,
yeah, yeah.
right? So I think I would just like to thank Anjali for taking her time, and I know that she has been traveling from one city to another city. Yet she made sure that she will give this talk, not just for the benefit of people who have joined in the participants. We are, I mean, I've got her consent to record this talk and host it as part of the TLC channel of Shastra, so that this this kind of constant engagement with the tool and the reflection on how to use the tool, that's what makes human learning something not replaceable by AI does not has this intent, at least as of now, to do this research, but we humans have this intent. And we need to reflect as educationalists, as students, be it college teachers, university teachers, and school teachers. And I, on behalf of all of us who have joined in this TLC Talk online, my hearty thanks to Anjali.
Sure. No, thank you so much, sir. And
Thanks
again,
a
yeah,
lot.
thanks so much for all the questions. I see that there's a request about sharing the paper. I can share this presentation with you and you can definitely take a look. But yeah, thank you so much.
Great. Yes. Thank you. Thank you. I'll stop the recording.